Hmm. 6. Okay, yeah. Um, so it seems like I can solve it using any BFS or DFS traversal. Like if I consider it as a graph problem, and from uh, each element, or let's call them nodes. From each node, which are one, I'll run a BFS or DFS uh, to and only traverse to nodes with value 1. Yeah, neighboring nodes which have value 1. So that would give me, yeah, and then I think I can maintain a counter that I'm how many times. So at the same time, I'll maintain this memory map where I'll mark like which nodes are visited, and then I can maintain a counter that how many times I have to run uh, BFS or DFS. Yeah.
Yep,
So, yep.
that sounds a valid solution to me. I don't complicate this. This is pretty straightforward. Like what you said, this
Mm,
just a straightforward graph problem.
yep.
But before you
Yep.
code, I've got a question for you. So,
Yep.
what's your time and space complexity for the approach that you just described?
Yes. So, space complexity would be n square, where n is the dimension of the matrix. Yeah. And time complexity. Let me see. So the time complexity, let's say I use DFS, is n uh, o vn. Yeah, number of nodes. Uh, but I'm running it for each node. However, I run DFS only if an element is not visited. So I think it still be same as one DFS, which is of Vn. Yeah.
Vn, can you describe the parameter v and n?
Yeah. Sorry, it should be E. Yeah. Um, V is the number of vertices, and E is actually the edges. Yeah, yeah. Uh, if it is really V into E, um, so let's say if it is a strongly connected component, like fully connected graph, from each node there can be V vertex or V edge, and I'll visit all of them. And then, yeah, I think this should be the time complexity should be number of nodes plus the number of uh, E is actually the how do we call the out uh, maximum number of edges a node can have.
Mhm. Yeah. So basically, it's the number of edges plus the number of nodes.
Mm.
Vertices plus the number of edges, basically.
Yeah, yeah, yeah.
Okay. Uh, yeah. Feel free to code it up and you describe your approach already. I think you're good to go.
Okay. All right. So I will maintain um, mm, Henry matrix is a 2D matrix. So I have So I'm supposing that it's a 2D array of same length and width.
Not necessarily the same length and width,
Hmm. Okay.
but the matrix you are given already. Basically, you have the
Hmm.
entire um, matrix.
Okay. So I maintain colors. Yep. And then I maintain counter. What else do I need? I need let's DFS on the metrics with colors and starting point. Yeah, I'm maintaining a stack to run DFS. Marking the color by one when the node is visited, and then visiting all the neighbor. So for visiting neighbor at uh, at I and j, I will visit I minus visit, I and j. I visit I comma j minus one, I plus one, comma I minus one, comma j, I comma j minus one. Search. Okay, let me just push them and then I'll add the condition. But before pushing this to stack, I need to check if it is a valid value. And for that, I can check. So I'm going to need n n is number of rows and n is number of columns. So I is number of rows with I plus 1 is less than n. Hmm.
Can you describe the variable colors
Yeah,
and how do you use it?
yeah. So I'm initializing. colors as a 2D matrix, same dimensions as binary matrix, with all values set to 0.
Okay.
Uh, and then, uh, so the purpose of this colors is to maintain the nodes which are visited and which are not visited. So as soon as I visit a node, I mark it as 1.
Okay.
Yeah, and in the end, so this will help me to mark which to determine which nodes are not visited, and they are like part of island. They are like 1.
Okay.
So now I'm using DFS, like using a stack to trace which nodes to visit next, and then marking the which when the node is visited, marking the color, and then I'm so these 4 lines are kind of visiting the neighbor nodes of that particular node ij. So there can be 4 neighbor nodes, right, at I plus 1 and I minus 1, and similarly. But for that, I need to check if I'm not crossing the array bound conditions, like if I'm not exceeding or going below 0. But also, I'm checking if that node is not already visited, like if it is not 1 already. Yeah. So
Okay.
that's what I'm trying to do here.
Okay. Sounds good.
Okay, so after wisdom, pushing the elements to stack. Yeah, this should be done. So I ran.
Can you describe how do you use INJ?
Yeah, so at line 21, what I'm doing is to just parse the binary metrics one by one. Uh,
Right.
and as soon as I find binary metrics which is 1, uh, if it is 1 and colors is 0, then I know that okay, I need to run DFS now that I have found an island. So I'll like go and traverse the neighbor nodes. But
Okay.
at the same time, I'll increment my counter uh, and pass the metrics, colors, and the starting node to DFS. DFS will update run the DFS on this node and update metrics and colors. So next time it is not used. And then I think I just need to return the counter. Yeah. Um, okay, let me go through this. Overall, this should be the logic. but let me see if I'm not missing anything. So colors where then I created colors with zero. This should be okay. Yeah. Can I run it?
Mm, sure, you can try, but I doubt this is a complete code actually.
Ah,
Uh,
okay.
yeah, I mean, you can think about why. I mean, you can try to run,
Hmm.
but I think I'm missing a few key things in here though.
Okay. Do I understand the question? Oh, oh, sorry. Yeah, that was very silly. This is incorrect. Okay. Primary is set and color is not set.
Let
IRNTF
me know if
doesn't
you want me
do.
to help, and if you, I mean,
Yep.
if you want to keep continue, I'm gonna let you go. Let you continue. If
Okay.
you want me to help you, let me know.
Okay. Okay. I'll try for 1 2 minutes. Yeah.
Okay.
Um, yeah, I think I'm closer. Just missing some corner case. So the answer should be six, but somehow colors. If color. Oh, oh. I need to check if the element is set as well before I go there. Oh, that was just. Uh, looks okay now. Yeah. Can I run
Hmm.
tests?
Yeah. Yeah. Try it. Yeah. Let me know if you want me to help you.
Okay. 0 0 1 0. So answer should be 2. Expected 2, but I returned 3. Strange. What's so special about this? Okay, should be something wrong with my conditions that I'm unable to visit. Hmm, If I plus 1, Oh, MJ should be checked. M rows and columns. Yep, works.
Good stuff.
Okay, I quickly think about what were the silly mistakes I did. I used incorrect. Uh, I did not pop. That was like really stupid. And then for visiting the next node, I did not check for metrics. Yeah, another silly mistake. And I used N instead of M. Yeah, yeah. I think I was just not being careful.
Okay, but yeah, so I think you have done well in this section. Let me give you some feedback, given we have a few minutes. So yeah, so you've done well. You know the approach. You're a quick thinker, and I didn't provide much help actually. I just be sitting here, and then you work your way out, and I ask you some questions, and then you answer them really well, and edge and vertices. And time complexity, you struggle a little bit, but you kind of figure it
Hmm.
out yourself, which is good. So a few things, if I was you, I would have done. Okay, and first thing is the checking on the constraint. I didn't hear you. I mean, even though you are given constraint, normally you're not given in a real interview. So if I was you, I will ask some more question
Okay.
about edge cases about constraint to prove
Okay.
that you are a well thought thinker. And secondly, it's about coding. So I would appreciate as an interviewer that you talk more about your coding because
Okay.
I interrupt you two times to make sure that I
Hmm.
following your thought and make sure that you know I sometimes for example when I was asking you what does the color
Yep. Yep.
do,
Yep.
I was actually confused because the naming is not exactly it's
Very good.
color.
Yeah.
Yeah, probably if I was you, I would name it like a visited or
Visited.
seen.
Yeah. Yeah.
Yeah, so
Agree.
that's something to prove that you are better programmer than others.
Yep. Yeah.
And I had a mistake like that all the time, so I get criticized all the time by other prammers.
Yeah.
Um, and another one is the checking the condition. You figure it out
Hmm.
yourself, which is really good. But in a real interview setting, we probably don't have an IDE that you can run the test cases against. So I would run it mentally on some test cases you can generate, um, and yeah, do a dry run, verbally, mentally, and just run it on a piece of paper by hand. Sometimes it will be really helpful for debug. And the last piece, I get criticized a lot. Uh, is by another because I interview a lot of people already. Like I interview like a 30, 40, I mean almost
Oh.
50 now.
Okay.
So yeah, so I'm trying to help as many
Yeah.
people as
Yeah.
I
Yeah.
can.
Yeah. Yeah.
So it's about the coding style. As I had a I had this problem really badly. I was like you got really jammed this code. Like I heard it
Hmm.
from a guy who was a friend working in Google. That guy when he interview people, he really like nitpicking on the style of the coding because there's some
Hmm.
spacing in here and
Mm-mm.
some spacing
Okay.
in
Okay.
here. So that can really
Yeah.
set you apart from other normal programmers. Like this is the coding style, naming convention. I have yeah the color. Also, the problem that I
Mm.
had, I don't see this is your problem. Is sometimes I get mixed between. If you see me do it again, please criticize me. Is I mix between
Yeah. Yeah.
camel case and underscore, which I should be like
Yeah. Yeah.
consistent.
Yeah.
I don't see that's a
Yeah.
problem for you. So, but I just want to put a note in the back of your pocket so you don't make the same mistake as I do. And yeah, so I think overall you have done well. But I feel things that if I was you, I can improve upon.
Yeah.
And
Yeah.
yeah, I think you pass all the cases. Well done.
Yeah. Yeah, I think the feedback is really great. Like these small things, like we oversee them, but they do matter, especially for software engineering interviews. Like people do care, software engineers, interviewers do care about these things, especially at good companies. Yeah, I think pretty good feedback. Yeah, thanks.
Yeah.
Uh, I'll
Yeah, not
write
necessary
down.
to. I mean, I'm a junior programmer, but I've seen a lot of senior guy. They still have like a
Mm,
really jammed, not well
mm,
coded lines. So,
mm,
um, but I this is the feedback that if somebody passed that knowledge to me, I'm just expanding the
mm.
knowledge to everybody.
Yeah, yeah,
So
yeah.
just and also another one thing is the spacing. It's a comma and it's line 18 like this, so it
Yeah,
looks
yeah, I
better.
agree, I agree. Yep,
Yeah.
yep.
Other than that, it looks good and clean and it's good.
Nice. Okay. Yeah.
All right.
Thank
Yeah.
you.
Do you have any question for me?
No, not no questions so far. I think we can swap.
Okay. Yeah. I don't have any follow up as well. And yeah, you have
Okay.
done well. Thank you.
Okay. Thank you.
Yeah.
I'll swap.
Okay. Now you see me struggle. Oh. Okay. Shifted array search. Let me see what do I get. A sorted array of distinct integer. Shift array is shifted to the left by an unknown offset, and you don't have a pre-shift copy of it. For example, 1, 2, 3, 4, 5 becomes 3, 4, 5, 1, and 2 after shifting it twice to the left. Okay, so given shift array and integer num, implement a function shifted array search that finds and returns the index of the num in shift array if num isn't in the shifted array. Okay, let me see. I'm still a bit confused about what it's asking. Uh,
Yeah, I can explain that.
yeah,
Um,
please.
so there is a sorted array which has been shifted by some integer, like by three elements or four elements. So in this example, it is shifted, like circularly shifted by three elements. So I initially it was 2, 4, 5, 9, 12, 17, but three elements are shifted and taken at the. You get the meaning of shifting, right? Like circular shifting.
Yeah, so I make sure. So I given okay, and let me see.
So you just need to find how many elements are shifted. I can give you
How
an
many?
example if
Okay.
that helps. Okay, let's consider this. So this is a normal sorted array, right? And it does not have to be like, uh, yeah. So this is normal sorted array, and let's say if I shift it, like move the last element to the top, it would become something like this. So I shifted it by one. I shifted it once, and then let's say I shifted it twice, then 40 would become at the top. So this is what happened in this example where the original list is shifted three times. So if you
Right.
shift
Yeah.
one, yeah,
Yeah. So basically, the 9 and 12 and 17 being pushed to the
yes,
front.
yes,
Okay. Okay. So what do I need to do? I have an output of
find
three.
how many
Find which one?
shifts, how many shifts are there?
Find how many ships are there. Okay. So what
No,
about the
sorry, give me a second. Given implement a function that finds and return the. Oh, sorry, not shift. Uh, uh, find the read. So you are also given a number. So forget about k. You don't have to worry about how many times it is shifted. You just
Right.
know that this element, this array can be shifted, like a sorted list can be shifted. And the reason I'm using can is like it might be shifted 0 times. So it is like a normal array, an edge case.
Oh,
Uh,
so basically,
yeah.
I need to look for that number that is a target that I'm looking for.
And then yeah, you search that number in this shifted array. So let's say if you just run a linear search, you find the index and you return the index of that element.
Right. Okay. Perfect. Perfect. So this looks like somehow sorted, but it's like crooked.
Yes. Yeah.
I think the approach that right. I mean, if we can do it, a brute force approach would be I just go through each one element and then bam, hit that one, and then I'm done. But I don't think it's
Yeah.
I don't think it's that easy. This one, I think it's more like a binary search problem.
Yeah.
And I'm thinking about log n to improve the space a little bit. And for the
Space.
uh, yeah, for space it's gonna be all one. It's gonna be like I have to do like a
Yeah. Yeah.
two pointers like left
Yep.
and right,
Yeah.
and then find one. And that's what I'm thinking. And yeah, but this is the challenge is coming to me is that it's not completely sorted. Like
Mm.
there's a shift, and then
Yeah.
again. A few questions I have in mind. So, do I have
Yeah.
what's the possible? I mean, let me see the constraint. Yeah, okay, okay. I was going to ask you the size. What's the possible size of this array? Um,
Can be really large or can be empty.
okay, so it
Yeah.
can
So
be something
given
like
there's
this.
no constraint on the length, so I think it's better to assume that it can be from 0 to a very large number.
Okay, so maybe from 0 to 1 million. I'm gonna say.
Yeah. Yeah. Yeah.
And is it possible to have like a repeated numbers?
Hmm.
Let's say if
Let's
I'm looking
start
for
with non-repeating. Yeah.
okay. Good that I asked. So it's not repeating all the distinct integers, and also the number can it be negative?
Can be. Yes.
Okay. I don't think the changes solution whole bunch, but I'm just asking first. At the back of my pocket. So before anything, I'm gonna as we. I actually hear you that you're not nodding when you I mean let's say binary search, so I'm gonna go with that approach if you like it. And but the problem is this is not a standardized
Yep.
binaries. It's not standard binary search. So how can we make it the way that we want? Let me try to work on an example. So let's say I'm just going with this guy over here, and I'm looking for the two. So for a standard template for I'm gonna write in some pseudocode in here. I have a left pointer. I'm gonna point it to 0. I have a right pointer, which is the index. I'm going to looking at the length of the given array. In this case, called a shifted array. -1 because it's the last guy of the index. Okay, so for a standard binary search template, while left is less than or equal to r, right? And if they are, I mean, the two pointers, they're not crossing over, and I can do uh, binary search, basically. So if, oh, okay, so I'm gonna have the mid guy as well. So the mid guy is gonna be, well, it's gonna be the middle of the 2 points. Take a integer division. So I will always have the integer that I can use as an index, and and then I have the number. Maybe I'm gonna call it I don't know. Maybe I could call it cur. I just stand for the current number I'm looking at midpoint. So now I'm gonna do some comparison. If if the curve is less than the target, I'm gonna call it it's called num, right? If the curve is less than the num, that we are undershooting it. So maybe we can improve by the lower bound. The lower bound will be, let me think, am I right? So we are, yeah, the lower bound should be higher than what we had before. And else if we are overshooting it, which is in that case is to be the current number is greater than num. So what we're gonna do? Oops, I think I've probably put it over here. Yeah. So if we're overshooting it, I'm gonna reduce the upper bound, which is becomes oops, I found a bug in here. So it should be the lower bound become the mid and the upper bound become the mid on the flip side. Else means we are exactly on the target. So we are basically done with it. And what we can do is just return the index right away and then break out the whole thing. But this certainly is not working in this example because it's like shifted, right? So let me think about the way that to get around that to make it work. I think at least I have some pseudocode in here. Let me think. So I'm going to walk through this example. Maybe I can have some idea to see how it works. So I have a nice 12, 17, and so in the beginning, I have a left at the 0, and the right is equal to 0, 1, 2, 3, 4, 5. It's going to be 5. And the middle point is going to be 0 plus 5 is 2.5. I take the floor, and it's going to be 2. And the current number that I'm looking at is going to be the index of 2, 0, 1, 2, which is 17. And 17 is on the side is increasing, but it's too much. Let me think. Yeah, let me think. So it looks like yeah, in this case, sorry for the silence. I was thinking. So for this case, I'm at 17, which is bigger than 2. So I should probably look at the left-hand side, which I should lower the right. And then if I follow that code, the right will become the midpoint and the left is not changed, which is still at 0. And then the midpoint and that becomes 1. And yeah, it wouldn't work that way because I will keep searching on the left hand side and I just become a dead end to me. So obviously it's not working. Let me think. So because I'm overshooting the target and it's not necessarily on the left hand side because it's shifted. In this case, it's actually on the right hand side. And let me think. Let me think a clever way to do this. The problem is we don't know where it's being shifted. Otherwise, it'd be easy. You just flip it back. Let me think. I'm just writing down on a piece of paper, two
Yeah,
lines
sure, no
going
problem.
into yeah yeah on a. I just want to describe my thinking while I'm working on the problem. Um, mm, Let me think. Right hand side.
I'll go and use washroom real quick. Yeah.
Yeah. Go ahead. Yeah. So how do I do this then? Just shift it. Crap, I don't know where that is. Oh boy. Any hint that I should? How can I
Uh,
somehow modify the binary search?
yeah. So now you have realized that like a normal, you just have to modify the binary search to account for the shifted part, right? So I think the only trick here is like when you're modifying, you take care of all those cases, like if your mid is in the left shift, or if it is in the right shift, or if it is at the, I think the first part is if the if your the element is at the right side or at the left side or right side compared to your mid element. So you just need to check the values, compare the values of mid element with start value and end value to determine if you are at part of right shift or left shift, and where do you have to go. So see, once you know that you are part of right shift or left shift, then you can determine where this element would be.
Ah,
So
yeah.
okay,
Okay.
so this is one way to do this. One simpler approach. So in this, we just like edit, like tailor our binary search, right, to run it on a shifted array. But there is one simplified solution using binary search. Okay, let me see how I give a hint. So, can you think of some way that you that if you can use a normal binary search to find that element instead of using this complicated binary search, if you can use a normal binary search, so you know that you have two different sorted lists now, right? It is shifted. So at some point, we have two different sorted lists.
Maybe, yeah. The thing is, I have to find the breaking point,
Yes,
and
yes.
then I can
So,
use. Mhm.
yes, yeah, run a binary search on the right list, and that you can know from the endpoint of the two sublist.
But the problem is looking for the breaking point is going to be big over n though.
Is it?
Well, it's going to be comparing the left guy and the right guy, right? And then keep comparing until the point where the right guy is lower than the left guy, and that's the breaking point. And in the case where if the breaking guy is at the end, it's going to be taken the big old n.
So, in your first approach, you are running binary search on a shifted array to find for the element. Can't you run a binary search to find for that breaking point, to look for that breaking point?
Uh,
So it's not very different, but it's a bit simplification of your first approach, that you're not looking for an element, you're just looking for the place where it increments instead of, okay, decrement instead of incrementing the values. So you get what I'm trying to say?
Yeah, I'm thinking, but I was also thinking about the first approach you had described.
Yeah, yeah,
So the first approach you described was I look into the boundary point to make sure that is that bigger or less, and then to
yeah,
compare that, use that information to compare that is on the left part, on the right part, right? So if I go with that approach, um, so essentially I have two numbers in here. I have the current number which is 17, and also I have the left number which is in this case going to be 2, 0, 9, and the right number, okay, right num and left num. I'm gonna call it, and then I look at the boundary point, which is in this case is gonna be 5. So it's easy to find these three numbers, right? 17 is greater than 2, and then 9 is also greater than 2, and then 5 is greater than 2. So I know that it's gonna be on the right hand side, because the left hand side is gonna be 9 is already greater than 2, and then still increasing, right, until the breakpoint. And then the right hand side is bigger than 5, but the right hand side, that is the highest number on the other end, right? And if I can use that, yeah, I think maybe, am I making sense?
yeah,
If we do that, if so, let's say if I generalize this thing, so if the left number is greater than the num, and that means it's not on the left hand side already, it must be on the right hand side. What we can do is to have the right equal to the mid, and let me think. However, on the other end, else else if, so well, else means to put it else first. So else means the left hand side, that number is less than that, which I'm okay. So if that is in the case, it's gonna be the right hand, yeah, so the left hand side is gonna be the left pointer is gonna be equal to 0, because I can look at the left hand side of the midpoint. Um, but the thing that I'm thinking is, if the right number that is greater than the num, that means it's okay. So that means it must be on the right hand side at this point. So the left is gonna be equal to the midpoint. Otherwise, it's on the other side again. So it's gonna be the right is equal to hold on. I'm not sure if making sense about myself now. Uh, so if the right number is greater than a num, and I know that's on the right hand side, so the left is equal to the mid. Okay. Otherwise means the right number is less than num. Yeah, that means it's on the should be on the left hand side. Should be on the left hand side. If that's on the left hand side, yeah, the left Well, the left will be 0. Yeah, I'm not sure this is gonna work though. And then on top of that, I'm gonna run the binary search on this. Uh, yeah, let me try to do a dry run. I'm not sure this is gonna work. So
Okay.
I have a left and right, and the current number is 17. It's a middle point, and the left number is 9. Right number is 5. In this case, is the 9 is greater than 2. So let me think. 9 is greater than 2. So the R becomes the midpoint. In this case, it's gonna be 2. And also the right number is greater than the num. And in that case, the left is equal to the midpoint, which is 2. Hold on. Yes, no, it does not work this way. So let me think. So if that number is greater than that, and that's the number is 2. I mean, the number is impossible on the left hand side. So uh, oh boy, I'm running out of time. If the right number is greater than the num, let me see what do I want to do with this. So 17, 9, and 5, and the target is 2. So I should look at this side. Oh, okay. I think I know where I messed up. So yeah. So if the left number is greater than a num, which I should in here I should the right it should be the midpoint, and then the left. No, the right should be and should be right should be the right. The left would be the midpoint. On the flip side, if the on the flip side, the right would be 0, the left would be um, what I think this is the condition I'm gonna add. Like if the left number is greater than a num, and that means it's on the other side. It's the right. Yeah. So, but how do I blend into here though? Oh boy. But how do I blend into here? Hmm.
I can give some hint.
Yep.
So, hmm, uh, So now you're using approach one, right? Just want to know where to move. Uh, First condition would be if element equals to the mid, then you just return. Otherwise, you need to know whether to go to right hand side or left hand side. Uh, the first condition to check is if actually um, if your current element. So do you see on line number 8? So here I'm trying to understand. I'm at mid, right? I'm trying to understand if the end element. So if I'm at part where it is actually shifted or not. How do I describe it? How about you write your uh, approach in an algorithmic way, and then let's see where it needs to be corrected. Yeah, then we can like iterate over it.
Okay, maybe I can. I'm running out of time. Maybe I can quickly put it in the code.
Code,
Thank you
okay.
once again. Yeah, thank you once again for your patience.
Yeah, no problem.
So, luckily the pseudocode I think kind of working. On so yeah, so in here and where we need to correct would be
Mhm.
look at
So,
yeah the end and the begin and the I think the left number and the right number. I'm gonna put it over there as well. Yeah, so you have something like a left num equal to the shifted array at the left index, and then have the right
yeah.
num equal to the shifted array at the right index. Let me think. Also, I had something like this. If the left, if the left number, uh, the left number is greater than the current number, uh, that means it should be on the right hand side. And what I'm doing is to the right index will be the current right index, and then the left index will be the middle index of the current midpoint. Otherwise, it will be okay. Otherwise, the left number is less than the number that we're looking at, and the right will be at the midpoint. The left will be zero index because basically we look at the left part. And then in this point, I'm gonna do a binary search on um, on it. So you know what? I think I'm time out. I will try to work on it after this section.
Okay, okay, okay. Do you want me to give you more hint for later, or
Yeah, yeah. What's your feedback to my code now?
uh, yeah, I think you are still. I mean, you are very close. It just like you have to think more about uh, looking at the last and first element to determine where to go next, whether to go on the left and whether to go on the right. I think the only trick in this program is actually uh, yeah, to determine your position in the shifted array, and then determining where this element. So from what I mean by determining your position in the shifted array is whether you are in the left shifted array or you're in the right shifted array, uh, and then where this element would be compared to your mid position. So one check is, of course, which you have implemented, you compare the current value with the desired number, but then you have to look for the start and end index as well to determine where to move. So, like for example, at line 30, you check if the current element, the mid element, is actually larger than the end element. So what does this line tells you? That you are at this position where it is larger than the end element.
That means the breakpoint is after the midpoint.
Yes, so you are at the left side of the list, right? So now you have determined that you are at this first part of the list. Now you compare the the desired number with the current value to determine where to go. So before deciding where to go, you need to determine which part of the list you are, whether you are at the left part or at the right part.
Oh, okay. And this is the gate that let I mean line 30 is the gate that lets me know
Yes,
that is I'm before the breakpoint or after.
yes. That's the
Oh,
important
okay.
thing to determine first.
Okay. I think yeah, I think you mentioned the second approach. That's probably easier for me.
Yeah. And that's why I mentioned this because in terms of handling corner cases and implementing code, that's much easier because determining that breakpoint is much more easier than this because of the less number of corner cases. In terms of approach, both are very similar, right? But the number of cases you have to handle in determining the pivot element is much easier than this. Yeah.
But what about time complexity? Is that
Log
which
in.
one?
No, so yeah, so even for finding that breakpoint, you can use binary search, but you run binary search in a way that you're not looking for an element, but you're looking for an element where it is less than the previous element. So every time for mid value, you check if this element is less than the previous element or not. If you reach a stage where your current element is less than the previous element, then this is the breaking point, right? That's the property of the shifted array, right?
Hmm.
But if
I'm
it
thinking
is not, sorry.
I'm thinking about how would you use a modified binary search to look at the breakpoint.
Yeah, that's what I'm telling you, right? So you just instead of like in normal binary search, you check the middle value with the desired number if they are equal or not. But in this modified search, you check if the element at the middle value is less than the previous value. That's the breaking point. Because in the whole shifted array, there's one position where where the element would decrease, the right? Otherwise, it's all increasing. If you see this example, the values are increasing until when you move from 17 to 2. Something which you mentioned in linear search, right? You will see where it is decreasing, and then you will know that, okay, this is the breaking point. So now you're trying to do this using binary search to reach the element where it is smaller than the previous element. Okay, so let's say you run your binary search in the first iteration, array mid is less than array mid minus one. You reached it, you return that, okay, this is the pivot element, uh, breaking element. But if it is not, if the previous element is greater than the current element, then you need to know whether the breaking point is on the left or on the right. Are you following me?
Yeah, yeah, I'm
Yeah,
trying to.
yeah. So we can take this example. Let's say your mid reaches 4. I'm taking the example from the question, right? So let's say you reached 4. Now you check, let's say you reached 2. You check that, okay, previous element is greater than the current element. So now you know, okay, this is the pivot, this is the breaking point. You return it. But let's say you reached 4. Mid is what, 0, 1, 2, 3, 4. Mid index is 4. Element is 4. You check, it is actually greater than the previous element. So this is not the breaking point. But then you need to know where to move, whether to move on right or whether to move on left, right?
Yeah,
Yeah. Now think in this example, you are at 4. You know that this is not the breaking point. Now, how would you know whether the breaking point is on the left or on the right? How would you use the first element or the last element to determine if the breaking point, if the shift is happening after this or before this?
oh, maybe I can check out the endpoint of the two
Yes,
intervals.
yes, yes. So in this case, you check if 4 is greater than the first element, 9. If it is, then the left sub array is okay because the first one uh, is increasing so far until this element, so that's okay. But in this case, it is not. So you know that okay, the shift is happening before this because I'm at this point where the elements were increasing but that decreased.
Yeah, yeah.
Yeah. So yeah, that's the so you just move to left in this case.
But it can be a case where it's increasing a little bit and then decrease and then increase again and then
No, no, no.
until a
There's
point.
only one shift. What? There's only one shift, right?
Let me think. Well, it can be the case where it be like this. So it's gonna be like 1, 2, 3, and then decrease, and it become like a two. Maybe yeah, 1, 2, 3, and then now becomes maybe two, maybe two, and then 4. If I compare this number,
No,
it's
this is
still
an invalid example, right? So you are given that a sorted list has been shifted. This is, I mean, this does not look sorted to me, shifted to me. A sorted list has been shifted. How
oh, okay.
this is
Oh,
a
okay,
sort,
okay,
yeah.
okay. Yeah. Okay,
So
okay,
yeah, I
okay. I
think
understand you now.
that's important to know that there's only one breaking point because it's a sorted list shifted. So you have two sorted lists. There's only one breaking and that breaks into two sorted lists. That's the most fundamental part of this question. So yeah, I think that's the only trick that you are at this position. You compare it with the first value or the last value to determine if the shift happened before this or after this. So now you can use this to to determine the breaking point and then run the binary search on that sublist, or you can extend it to like after determining where the shift is, now you compare the current element with the desired element and try to figure out where to move into, which direction to go into. So that's why the second approach, where you find the breaking point, is kind of simpler in terms of implementation because of those corner cases, etc. But
Understood.
yeah, I mean, I would encourage that when you do it, try with the second approach first, and then once you implement it, then think of the first approach.
Okay, okay. That's very good advice. And yeah, I think I'm already
Yeah,
the
yeah,
time is
okay.
already there. Yeah.
Yeah, yeah.
So I'm not sure if
Uh,
you have a few more minutes to network.
Yeah, sure, sure. Let me see if I have some other feedback for you. Um, yeah, I think your communication skills were excellent. Like you were like talking through the problem, describing each of the every step. I didn't have to ask anything. You made sure you clearly communicate every step, and I really like that you checked all the constraints and condition, even if there some of the things were like actually most of the things like very necessary to know, right? Like the duplicate elements and etc. Yeah, I think that's definitely I can learn. Uh, and yeah, I think in terms of improvement, mm, yeah, in terms of like I would say that for binary search you can use some more practice. First of all, so initially you started with implementing the binary search, normal binary search, which was the right approach. But like you should be so much comfortable with implementing binary search that it should like take 1 minute to just write. It should be less like memorized, right? Like uh, and and I think having more practice on binary search would allow you to think of this kind of problems because I think I did a decent practice on binary search, and when this question came to me, I was able to think of the approach, the first approach, but took a lot of time in the implementation, like those corner cases, implementing those corner cases, etc. So I would say that for this question, the most tricky part was to like implementing those corner cases. Yeah. So I think you can use some practice in binary search. Yep.
I actually have seen this problem before, and I couldn't recall it.
Oh,
This is
oh,
yeah,
oh,
and I this is such a shame that I couldn't recall. This is one of the popular question
that's yeah,
for
yeah,
Amazon.
yeah,
Um, anyway, I need to spend some time to do some review work. But let's do some networking if you have the time.
yeah,
I want to share with
yeah,
you a bit what I'm doing. Maybe I'm gonna ask you what you're doing right now, and also share some interview experience.
yeah,
And and actually, this is me. And
yeah. I'll ask.
I actually I can start it. What I do and what I've been interviewing and
Oh,
also
you
and,
have
and you
very
can
professional photo on LinkedIn.
well actually yeah I actually from a non CS background. I'm from math background.
Oh,
Eh,
oh,
Yeah,
nice.
so well it's okay. I think I've been doing decoding and prompting for 4 months now, and I interview a lot of people on Pramp, and and for I'm actually now I'm a programmer for a bank in Canada. Um,
Oh,
yeah, it's okay.
you like
I
your background was not. No, no. I was surprised that your background is not programmer. Oh, I see. So you like recently changed when? In 2001? 2021?
yeah I
Oh,
started from as a program. I know programming, but I'm not like a strict programmer before this year. I actually
oh, you
changed
were
from
analyst. Oh,
yeah I was doing some
oh,
trading finance. I'm doing a lot of finance actually.
okay,
So
nice.
and now I'm doing a bit crossover between finance and computer programming. And yeah, so non-CS background, I'm from a math and statistics. For my interview experience, I interview with Google, and Google I think 2 months ago. I passed the first round, but I didn't get past the second round because I got asked a very tricky question where I was asked to code up a Python iterator. Um,
Oh, oh, damn.
yeah, so I keep sharing. I've been keep sharing my failure to my friends, also friends on Prem. Make sure that people don't make the same mistake as I do. That was a toughie. I must say, it's an object coding problem. Uh, at that time, two
Yeah.
months ago, I didn't know. what it was iterator. Now I know back and forth. I learned it the hard way. Learned it, learned it the more for my failure. So the first Google problem was not that bad. It was just a regular. I don't know. It's like scheduling something like that.
Okay, okay.
It's not crazy. Like
A
it's
medium
not.
level problem.
I don't think it's even medium. I think it's like someone to get on bus and how many capacity we have to keep track of. It's pretty easy actually. The
Oh,
first one.
oh, oh, okay, okay.
So I get misled by that. I thought, oh, that was the label of Google. I went, okay. And then the second one was like I get bombed so badly, and also I
Yeah,
get
actually,
interview.
the second
Mhm.
round was like not like coding interview, right? It's more like, I mean, not data structure coding interview, but a coding interview in general.
Well, it's more like how much you know about Python.
Yeah, 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 yeah. Not algorithm or data structure questions.
It's not the mainstream. It's not the mainstream problem that you come across like a you. I would think as a
Only
normal
code.
person, right?
Yeah,
Like
yeah,
only
yeah,
like I was
yeah,
thinking
yeah.
like a breadth search,
Yep,
DFS,
yep,
or
yep,
binary
yep.
search is like a more people will
And
think of.
I'm surprised because from what I've heard, Google always in the coding interview, Google only ask about the data structure algorithm question. Like this is the first time I'm hearing that they
Don't
kind of ask this.
don't get misled by that. That's what I that's I keep sharing that story with my all my friends. Like do not get misled by like some discussion on the street. They have a wide range of freedom to get choose.
Yeah, 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 yeah. Yeah,
And
that's actually the biggest problem with Google, right? Like they can ask anything, right?
the problem is they cannot reuse. They cannot reuse the pi problem. So leak code is only for practice, but not for indication. I might
Yeah,
say.
yeah, yeah.
Uh, yeah. So right now I'm preparing. I mean, I was in the stage of preparing for Amazon, and yeah, also Facebook. I haven't heard back from Facebook yet. So yeah, that's me. I'm still leak coding, still prompting. You see, I'm still struggling on a simple binary search. Yeah, even though I interview a lot of people, I sometimes some for some of the question I can do it quickly, and some problem I get stuck real bad. Right now on leak code I've done like I think around 200 in total. So but I forgot some of the problem that work on. This one I seen before, but I forgot about it already. So that's another problem for me. Yeah, so that's me. Tell me a little bit about yourself now.
Yeah, yeah. Actually, I have one question before I talk about myself. So
Yeah,
you mentioned that you have been using Pramp from like a long time, or actually have used like for 50 interviews, right? So do they keep on coming with a new question every time? Like, do they have this big question bank?
yeah, I use it for like a 3 or 4 months. I've been like I'm doing it like every other day. And it's this brand new question I'm seeing. But
Oh, nice, nice.
yeah, you might see a lot of question that you have seen on Leak Code before, but they won't give you
Mhm.
a
Yeah, yeah.
exact same question you have seen in Pram
Okay,
before.
okay, okay.
Yeah, so they have a
Uh,
fairly large database. But the problem for Pram is that they have a I haven't seen a linked list on Pram. Also, I haven't seen an object design problem on Pram. Also, I don't see a lot
Object
of
design.
tree. Yeah, like a iterator object, right? You
Uh,
don't see them. Also, I don't see a lot of like a tree problems, and
tree.
most of them like a yeah, most of them like a dynamic programming, binary search, graph.
Hmm.
They have a lot of graph. So don't rely on the database. It's not perfect.
Hmm. Yeah, that's actually one problem. If it is like biased towards one kind of data structure, then you're not getting a good and if you're just using Pram, then you're not getting exposure to different kind of problems. So yeah, I
That's
think
what I'm saying.
just relying on Pram is yeah,
Every other day. I use every other day. I don't use like consistent every day. There's
yeah,
a problem
yeah.
with the database. It's very biased.
Mm. Okay,
Yeah.
okay, okay.
So tell me about yourself now.
So yeah, yeah. So I sent you the request on LinkedIn. I am working as a data scientist right now in Singapore. It's a company called Gojek. It's like ride-hailing company, like Uber. Um, yeah, so I started doing data science after my master's, but before that, I was working as a software engineer. Uh, so when it comes to structures,
Oh, you
this
were in China
DSA.
before.
Oh yeah, yeah. 可以说
Okay,
中
wow.
文。
Wow, wow, you can speak Chinese. That's you're better Chinese than I do.
一点。
I'm just kidding. No, no, I was from there. Yeah,
You're
go on your story. What was
yeah.
that?
So you're from China as well, or
Yeah, I came to Canada when I was 18. I've been in, yeah.
oh, okay,
So yeah, I was born in there actually.
okay, okay, nice.
Yeah. Anyway, go
Yeah,
on.
actually, yeah, I did my internship at Alibaba for 3 months in Hangzhou, and yeah, so that's what I have been doing. Yeah, I think for data structure, right? Like it's been 3 years, more than 3 years that I have not touched data structure. And last time also, because I'm like now doing a lot of, was doing a lot of data science until now, and did some during my master's, but that was like very little because I got into data science. So yeah, it's actually like picking all these things after a long time. And in terms of interviews, so this weekend I gave the on Amazon online assessment for actually for Toronto and Vancouver. I'm planning to move there, but I failed it. Yeah, the questions were kind of hard. The first question I managed to do, like managed to pass 13 test cases out of 15, which was about sub arrays, some flavor of sub arrays. Um, so I did it in O(n) square. Uh, the second question, yeah, only two test cases out of 15, which was even more difficult, like a question on subsequence. Uh, but yeah, could not find a better solution. So they just failed me. Like received an email yesterday that I have been rejected. What else? And I have I talked with an engineering, like the HR of Google. Google Maps team contacted me, and then I talked with the engineering manager there. Like they placed a call with them. So now I'm like in this phase of preparing for the Google. That's ML engineering role. So yeah, into the phase of preparing for that, and then have few interviews here and there about like small companies, but that is more for practice, not for, yeah, like not that I'm serious about. Yeah.
Yeah. So I'm seeing your data science. I got a few questions to ask you. So
Yep.
um, how do you? I actually asked a lot. I have seen the kind of. Well, I got asked that question by a lot of people already actually. About data science. Because people see my math background and they ask me why you
Yeah,
didn't go
yeah,
with the
I
data science route.
yeah,
Yeah.
that was my question as well. I was thinking to ask you like why not data science? Why not? Why SE?
I Yeah, I was thinking about that as well. It's more like a yeah machine learning stuff. I think it's just interesting. I think, but the problem is, I mean, for me, I think even like yeah, I'm seeing like NLP. Yeah, that's even for a data scientist interview, we have to do lead code as well. So lead code is not a yeah, it's not escape. I think I don't get to choose, and I don't get to be picky right now. If I'm like Google asks me as data science, I probably go for
Mm.
it. But I don't have a ton of experience on data science side. Even my background is mathematics. So yeah, but how do you choose though? How did you choose the big? I mean, what's your preference actually?
Now I think I clearly know, like 3 years ago, it was not clear, so I moved to data science. But now I think I kind of enjoy this intersection. I find that to be the sweet spot for me, where I do a lot of engineering work as well, not just theoretical data science or not just doing the POC stuff, not just analysis kind of work, but ML engineering where get to train some models here and there, but then spend a lot of time building services, systems around those models. So yeah, I think that's what I'm looking for now, like to still do data science work to train those models. It's kind of like working on engineering system which have machine learning models, machine learning flavors, instead of traditional software system where there's no machine learning going on. You get what I mean?
So you basically, I'm trying to understand. So you basically doing something like have a bit of both.
Yeah, yeah. So I think ML engineering is kind of that, right? Where you train some models, you focus on business metrics, and then for those business metric, you come up with some model, you build data pipelines, come up with some model, and then deploy those models or build the infrastructure around that, like the feature store, etc. Uh, yeah, yeah.
What's the difference between a data scientist and a machine learning engineer?
I think it's very difficult to answer because that depends a lot on the company. So, for example, at the company I'm working on, data scientists are meant to do machine learning engineering work as well, in the sense that we are responsible to take care of the system end to end, from training the model, from doing the POC, from doing the analysis, to develop the pipelines to deploy the model, build the production service around that. So, but how it is different from traditional software engineering is like we have the platforms to develop, deploy those models, etc. We do not like reinvent the wheel for everything. You get what I mean? So, for example, if I
Hmm.
trained a logistic regression model, I have this model binary. I would not build a whole Golang service just for the deployment of that model so that backend service can call it. But I we have this platform built by the platform team, which takes the model binary and like do the deployment. So for some of the part we do like plug-in of different tools, but we are responsible for the whole life cycle of the project. So to answer your question, first it varies a lot. In researchy kind of teams like Google AI teams like Google Brain. They the data scientists are like researchers, right? They do not do production stuff. They
Yeah, exactly. Yeah.
yeah. So yeah, I think that's the thing. But if I have to give a theoretical definition, then I probably data science. When it comes to data science, you're more focused on just the modeling part, but uh, also one big part is like to understand the business requirement, focus on business metrics, etc., which is very less in engineering. And that was one
Yeah.
big difference for me when I became a data scientist, that there was like a big focus on business metrics and business, uh, instead of when I was an engineer and all I cared was like to push code on production and deploy it and keep the like care about the health of those services, but now it is health of the business metrics. Yeah.
Yeah, I think from I certainly I'm not a data science or nor a machine learning engineer, but my interpretation is that from what I heard from people, is that data science is more like they use data to answer business questions. To how do you make a data driven decision, right? Basically on
Yep. Yeah.
what
Yeah.
and a lot of SQL stuff, and sometimes it's not even machine learning model. They just want to get some insight from the try to
Yeah.
tell a
Yeah.
story,
Yeah.
maybe visualize the data given.
Yeah,
It's
so
already
that's
data
like
science.
analysis
Mhm.
work, right? When I said we do a lot of analysis work as well. I mean, ideally, that's meant for data analysts that you do visualize the data, understand the data, make insights out of data. But then data scientists end up doing that a lot as well because you need to develop a sense of what is going on in the business, what they are
Yeah,
focusing on, what are the issues, and then only you
yeah,
can solve the problem when you understand it very well.
yeah,
So actually, again, right, that these definitions are like so poorly defined that you will see that on Team Blind that a lot of data scientists in Facebook are just doing SQL and dashboarding work.
Yeah,
Yeah, so
exactly. Yeah, and the ML engineer is like it's engineering, right? You're basically building stuff. It's not necessary.
yeah, yeah,
They just gauge the data, what it looks like, have a feeling of the data.
yep,
It's not
yep,
necessary
yep,
only that. It's have you build it from scratch all the way to deployment, all the way
yep,
to
yep,
pipeline, and also the step by step. So
yeah.
that's my understanding.
I ideally yes, but again depends upon the team. Some of the team in some of the company or in some of the team, you might end up just maintaining some production service even if you are ML engineer. So as I mentioned, the definitions are very vaguely defined. It depends a lot on the team. Uh, but for interview process, I think they for ML engineer they look for engineering lead code and also machine learning skills. So that's one difficult part that like if you are moving from software engineering to ML engineering, you now you have to do lead code a lot, but also you have to do machine learning. So, for example, for Google MLE, I talked with the HR and also one guy who just cleared those rounds. And so there are two coding interviews, just normal software, like software engineering coding interviews, no difference. And then there is one system design, but that's ML system design, which is nowhere similar to system design. So there's not much preparation stuff online. And then there's ML theoretical, which, well, you can find resources for that. But yeah,
ML theoretical, are they going to ask you different models or are they ask you simple probabilities then?
uh, yeah, I would say that depends upon the company which you're applying for.
Yeah,
I know that Facebook for data science role they focus on SQL and then the
yeah.
basic probability and statistical knowledge and some machine learning knowledge, but mostly the theoretical part of it. But for Google, I think, yeah, the guy mentioned that no, actually, they do not focus a lot on maths and probability, like probability and statistics. They generally ask about the algorithms, and they sometimes ask you to implement the machine learning algorithm in Python at that time. Like if you, they will just ask you to implement random forest in
It's from
Python.
scratch? Wow,
Yeah.
Jesus.
Or at least they would like try to get some sense that if you're able to move in right direction, if not the whole code.
Yeah, I heard it from a guy from Pramp as well. He was interviewing a machine learning engineer with Google,
Oh, oh.
and yeah, he told me the same thing, like leak code, two leak codes, and then when he was in the machine learning round, he was asked by that guy was a professor from a some Switzerland university, asked him like really tough question. Like he was like, "Holy shit!" And he that guy is really experienced. That guy was really, really experienced, and he said, "Oh, he passed all the legal part, passed all the legal part, but just failed on the machine learning knowledge part." So that's really tough.
Do you remember what was?
I, I I'm not much. I'm maybe he
Oh
mentioned the
yeah, yeah.
question, but I don't remember exactly. I didn't know what
Okay, yeah.
exactly it was anyway when he
Okay,
talked to
okay.
me. And also to your point, maybe some to your point, maybe I let you go. Before I let you go, about the guy who interviewed me in Google. He is a machine learning researcher at California. And he said it's only like his on object detection is only on research, like only on research.
Hmm.
So like what you say is like it's not like from end to end building stuff, like left for research
Hmm.
stuff on object detection. But he asked that question is I don't think it's related to anything like that one. Only related to Python. Um, so I would suggest to like get to know Python a bit more before interview with
Hmm.
Google. Definitely
Hmm.
that's gonna be coming to helpful and handy.
Hmm. Hmm. Okay, okay. Thank you.
Okay, I'm gonna let you go and best of luck if you interview with Google. If you get on
Yeah.
Google, please don't forget to refer.
Yeah. Sure, sure. Okay.
Okay.
Best. Good luck for your interviews as well, like your job
Yeah,
hunt.
yeah. If you want
Yeah.
to get on Pramp again with me, let me know and send me a message on LinkedIn. And I wish you best
Yeah,
of
yeah.
luck.
Let's do it. Let's do it. Yeah, yeah. I'll ping
Yeah,
you
yeah,
on LinkedIn. Yeah, sounds good.
yeah. Best
Yeah,
of luck. See you next time.
yeah, yeah. See you. Bye bye.